Right. Hi, online. Afternoon. Right. So today we're going to take a look at conditions of equilibrium, and we're going to do the past papers on it. Right. So the first condition of equilibrium, the sum of the anticlockwise is equal to the sum of the clockwise. And the second condition is that the upward forces equal to the downward forces. Okay. So in this example here, if I said that this system is in equilibrium, watch here. Take a look up here. If I said this system in equilibrium, it means that it's system balance. It's not going to move from there. So if that happens, we could say that the clockwise and anti-clockwise moments are equal. If you look on the right-hand side, this is a what moment? Finger here, down in the force. This is a clockwise moment. You'll see that? And how do we work out moment? Force by the distance from the pivot. So it's force by x. Anti-clockwise moments is force by 6. So that's 2 by 6. So 4x is 24, 12. X is 12 on 4, which is 3. Right? So for this system to be in equilibrium, x has to be 3. You okay with that? Right? Just suppose I said, okay, well, find the force acting here now. Find that force F. All we have to do, come back here. Conditions for equilibrium. Can we apply moments? Anybody remember if F applies moments? Does this force F here have a moment? Anybody remember? No. When you're on the pivot, you have no moment. Okay? So the law we'll have to use in that case will be law number 2. The only way this can be balanced is if the upward forces is equal to the downward forces. So F is equal to 6. That's okay. So all we're gonna do now is do past papers just like this, but in disguise a little bit more, right? It may be a little more challenging. Okay. So we're gonna do some past papers on this. So go take a picture. Write it down. Write it down. Oh, sure. That would be like okay, share my thing. But oh, yeah, also for your time. But of course, you have to know a little bit on maths, right? But for the time. Okay. So it's something that you can look at so you can see things about for the time, right? I did one in physics, but I didn't. Didn't come out with it. That's good. Right. Before we start, there's just one thing I wanted to remember, right? There's something that we didn't do as yet in Newton's law, but it's just something I wanted to just add to your notes, right? Some that we didn't really do as yet, obviously. Put on there, right? And there's something I wanted to remember. It's called Newton's third law. I know I didn't show you it as yet, but you need it in questions like this, right? Right? If I were to give you something like this, right? Let's say, I have a plank, right? And somebody's standing on top of the plank, right? There are two forces on this plank. The obvious force will put is weight, and the next force called contact force, right? So, for example, if you touch the wall, right, and you feel something, if you touch the wall and you feel something, so what you're feeling is you are applying a force on the wall, and then the wall exerting an equal and opposite force on your hand, right? If you apply a greater force on the wall, what will happen? And you will feel a greater force as well. That is called contact force. Right now, you're in contact with ground. You are applying a force to the ground, and the ground is applying an equal opposite force on you. That's okay? So this marker in contact with this whiteboard, so this marker has a contact force. If it's not in contact, no contact force. That's okay? So I just wanted to make a note of this, right? This R is what we call contact force. Once you're in contact with a surface, you have that contact force. Okay? And then we'll go back to our first scenario on principle of motion, right? All right, now let's get out of this. Not on the L. Yeah, what are we going to do? We're going to step up and you look for, but put your name and say the right? I just have to go back to this, right? All right, so let's start here. That's the best I can do there, right? We don't need the words on top, right? The words on top is a wheelbarrow, it has stones. Oh yeah, we did. Right? Figure 3 shows a wheelbarrow and stones, but and what I will do is you will see all these questions, right? On your worksheet in the element. That's right. Same thing with physics, all these questions there. I don't have the years over. These are past papers. Okay, so you have them there in practice. I don't have solutions as yet because I don't work together. I'll make it solutions available next year. Right, what we're doing them in class. Right, just make a note of that. Otherwise, to draw the wheelbarrow, what we are going to attempt to do is to take that wheelbarrow and draw it like this, so it's easier to understand. Okay, so before you try anything, just do me a favor. The mass of the wheelbarrow and the stones is 43 kilograms. Right, that please. The mass of the wheelbarrow and the stones is 43 kilograms. Just make a note of that, right? And the rest I'll leave up there. Then it said the wheelbarrow is in equilibrium. So what does that mean? If the wheelbarrow in equilibrium, what does that mean? It means that the two laws I gave you will hold. That's okay? So once you see the word equilibrium, these two things will hold. All right? And now identify, take a little read. I don't know if you're all seeing it. Identify the nature, mass of the wheelbarrow, and the stones is 43 kilograms. 43 kilograms. Right? Part one. Part one is identify the nature and point of action of the third force acting on the wheelbarrow, and then write an equation showing the relationship between these three forces, right? How many forces you're seeing acting there right now? How many forces you're seeing acting there right now? Two, right? The applied force and the weight. Where is that third force talking about? The what is downward force? By the pivot now. No, right, it already have that the weight. That's the weight. So the weight of the wheelbarrow and the stones acting down the middle there. But there's a next force missing. Contact force, right? Where is the contact force? Between the wheelbarrow and the ground, right? Correct? So the contact forces right here. Let's call that R. Okay? So I don't want you to try to draw that, right? What I want you to draw from a plan. Where would the pivot be? On the end here, correct? Draw the reaction force R, draw the weights wherever it is, and the applied force here. That's okay? So instead of drawing the wheelbarrow, draw that plan. And put in the values, right? And then we'll try to answer the part one here. All okay with that? So we don't want to work with the wheelbarrow. We want to work with a plan because that's the easiest thing to work with, right? So the wheelbarrow and the color confusing. Right? So you should have a completed diagram with all those values, right? And that's kind of zooming back out there, right? Right. So they want an equation between the three forces. Right. So we're gonna try to figure this out. They want the equation with the three forces. The second thing they want is the weight. And the third thing is they want is that. All right, online. So this is what we have. So I remember this system is in equilibrium, right? So we have to figure out how we get in 1, 2, and 3. Look at the diagram. And which law you're going to use to try to find part 1? Huh? Oh. There's the equation of three forces. Equation, weight, and force. Where to find all those things. Good. Any ideas? Any ideas how to get the first one? Remember the system in equilibrium, right? So the answers have to come from here. Which one you think? 2, right? Upward equals to downward. Yeah, Alex, that's something good. So what do I write here? Huh? What? What do I write? Upward equals to downward. So what to write? What's the upward forces here? Which two forces acting upward? Right. So R and F equal to what? W. That's it. That's all they want. That's okay. Javi. Javi, pass me the next partner. How you find weight? How you find weight? What do you find out the weight? Mass by gravity. Next week we'll do a review on everything we did, huh? Right? And the mass is how much again? Mass was 43, right? And gravity is 10. Right? So work out that. Well, you do that in your head, right? So that's 430 newtons. Right? Online? Are you okay there? Narissa? Miriam, are you okay? All right, nice job, Narissa. All right, so we know that upward equal to downward, and we know that weight is equal to 430. Now for the challenge. Now for the challenge, Megan. How we getting there? I know the question didn't ask weight, but after we find out, I want R. I just like to add on that, right? Yes. How we getting that? Anybody? Think about it. We just used this, so you might be able to use this again, right? You might use the principle of moments. That makes sense? You might use the principle of moments. Well, okay with that? So we're going to use the principle of moments to find F. I will give you a startup. Hopefully it's helpful. So I wanted to take the moments. So exactly what I did in the last question, the example I did in the beginning of the class. Do the same thing for me. I am telling you where to take the moments, right? Actually, you tell me where to take the moment. Would I take the moments here, here, point 1, 2, or 3? Where do you think is the best place to take moments? 1, 2, or 3? 2? 2? But if we take 2 and we don't know F, and we don't know R, so we have 2 things we don't know. So that's a problem. So 1, 2, or 3. We can't take it at 1 because F will be 0. The moment there is 0. So we take it at 3. So take the moment at R. All right. So take moments at R and do the same thing I did in the third question. See which one clockwise, see which one anti-clockwise, and then work it out. And then she should tell us what we got. Right, Vishesh? Take your time. Taking moments about R, the reason I chose R is to eliminate R. Define for taking moments clockwise and anti-clockwise and see what we get. figure out which is clockwise, which is anti-clockwise. So that's the trick, right? The trick is to figure out which is clockwise and which is anti-clockwise. Right? Let me start, right? So as I said, for us to work out R, we need to know clockwise moments and we need to know the anti-clockwise moments, right? So Megan, W, clockwise or anti-clockwise? One on the pivot, one on the force, so it's clockwise, right? And how far is W from the pivot? 0.6. And then F should automatically be anti-clockwise. That's okay? F will be anti-clockwise, right? One on the pivot, one on the force. So that'll be F by, how far is F from the pivot? Force by perpendicular distance, which is 1.5. So F is equal to W by this, and we found W. W by 0.6 all over 1.5. Anybody got that online? Right, so that's 430 by 0.6 over 1.5. How much is that? $172 Newton. Check it and make sure. Yeah. Right. So all I did is that I recognize that I use Newton's I use upward equal to downward here. And to work out R and to work out F, sorry, I needed to take moments, right? So I took moments on the pivot, I found the clockwise and the anti-clockwise moments, I made them equal, and that's all. That's okay? Remember, you can have like the example we did last week, you can have more than one anti-clockwise, huh? Right? You can have more than one anti-clockwise, more than one clockwise. Okay, last part then. Again, R. Right? I know that W is 430, and I know that F is 172. Right, it's now pick on some people online here. So, yeah, then. You might help now. How again, R. So on the board. What you need to use on the board. You know W, you know F. How again, R. But the first thing you worked out in the question. But the first thing you worked out. Huh? No, that's just distance, no? What's the first thing you worked out? Part one. Right, upward equal to downward, right? Can you use this to help you find out? Yeah, R is what? Huh? How R will be 0.6. 0.6 the length. R is the fourth. And you get R from this, make R this subject here. What's R? R is what? No, make R the subject and the formula here. What will that be? R is what? Help them there. R is W minus F. Right? You can just make an R the subject here. Move across here. Right? And W is and F is what is that? How much? 258. All right. So that will be a breakdown question, right? Problem with it is that it's not coming with a plan, that nice and simple. It's coming with those yeah. No. Why you translate? Right? So again, what we say, we have to learn to take those diagrams and convert it into a plan. All right? Okay with that? And then apply principle of moments. You don't have to, if you can identify that weight is still clockwise and force is anti-clockwise, no problem. Right? But the plan just normally kind of make it a little bit easier. Okay? So we're going again. Next scenario, I think, is bicycle. Yeah. Oh no, say about the walk. All right, anyway. Well, yeah, let's say we can't have it. All of this anyway. How about I want to see this? All right, so I'm reading it out first, right? I'm reading it out first. So I'm going to take a picture and then zoom in on the phone, right? Figure 3 shows a bicycle of mass 15 kilograms. Yeah, take a picture and zoom. So you have to work with it as well, right? Right? So figure 3 shows a bicycle of mass 15 kilograms resting in a vertical position with the front and back wheel touching. What does that mean? If the front and back wheel touching Tishish, what does that mean? And before two what forces? Now, two, right? Two contact forces. That's all I'm looking for, right? Two contact forces, right? That's okay, right? Nice, Narissa. We didn't get Narissa online. Where we are? You'll get message to F Cupid, Arissa, Celine, right? So it rests right on the horizontal at point P and Q respectively. PQ is 1 meter. The center of gravity of the bicycle is vertically above O, right? So you know your weight will act down there. All right, so here's what they want, right? They want two equations that satisfy conditions for equilibrium. No working. Just two equations. So I want you to take this, turn it into a plan, and obtain two equations of motion. So, sorry, obtain two equations that satisfy equilibrium. So turn that into a plan. Turn that into a plan, and they want you to find two equations that satisfy equilibrium. No actual numbers are really good. Right? I'll just put in the 1 meter here, right? So we have R1, R2. What's the force missing there again? We have R1, we have R2, that is contact force. A force missing there. Weight, nice. So the weight will act along the center of gravity here, right? So let's see if we can convert that into a plan. Put R1 in the right place, R2 in the right place, W in the right place. And then come up with two equations. You don't have to solve it, right? Just come up with two equations. Right? That's go ahead. Think about it. Think about where you put in R1 and R2. Think about where you put in W. and then put in the little lines they gave you. Right. Huh? Yeah, I don't want to help you. But let's see where you put in your forces, right? Right? Because technically that's what's in there. Right. Well, think about that. It's not just there, it's a movement anyway. That's my intention. We don't have to think about that. You don't have to. Because if I were to raise flag, I would have paper that here. If I were to raise flag, you'll raise paper. So you can do that paper. Yeah. Very good, very good. Okay, look, that's a yeah, right. Right? Right, well, yeah, the trigonometry equation there, do this right back clockwise equals clockwise. That trigonometry equation. You can divide, they give you. One is full one is from. And let me see, so like, most of you all got a diagram right? Right online, I'm gonna show you diagram test now, right? So this could only pivot here, and this could only pivot here. It's based on where you're moving it, right? R1 acting here, R2 acting here. Hold on, let's log out here. Right? So R1 and R2, if you want to put it pivot, put it underneath there. And we know weight acting here. We know that here to here is 0.3 meters, I think. Yeah. And here to here, they said this whole length, P cubed. This whole length is 1. So it means that here is 0.7. That's okay? The diagram completed looks like that. Now we can try to come up with equation 1. What do we know? Let's avoid the harder one. Let's start with the easy one. Right? And we know what equilibrium upward equals to downward. Yeah? So scenario, what the equation look like? R1 plus R2 is W. Nice. R1 plus R2 is W. Now, now we had applied the principle of movements, right? Where you want to choose the pivot. Either one, don't matter. Right? You can choose it here or here. Both will give you a correct equation. So let's choose the pivot at P. Right? If I choose the pivot at P, then this moment here becomes what? Or would it be 0? Right? That becomes 0, right? This one, clockwise or anti-clockwise? This one, clockwise or anti-clockwise? Clockwise. This one here, anti-clockwise, right? So the clockwise will be W multiplied by 0.3. And the anti-clockwise will be R2 by 1. Right? Those are your two equations. Okay with that? Online? Anybody got up? Cupid? Anybody got up online? Miriam? Arissa? Celine? You got it? Okay. All right. It also worked out anything because they didn't give you enough values, right? So I get it. So they can do, but I can't all levels here. I take a picture because you do me now. What I will do is I'll compile all these in the worksheet and I'll send it to you on the group chat, right? So you'll have it. Gavi, you okay with us? 1 and 2? Right, so 2. Yeah, you have to take a pivot. Right? So 2, you have to choose a pivot point, right? So if you choose P, you have to work out which of your forces create a clockwise movement and which create an anti-clockwise. One on the pivot, one on the force, move in the direction of the force. So this will be clockwise, so this will turn anti-clockwise. How you find moment? Force by perpendicular distance. W by 0.3. R2 by that whole distance there is 1. That's it. We don't have enough input to continue. If we had weights and everything, we could have gone fine. We could have gone fine. So a cyclist hangs his bicycle. You all see the pivot for this one? Yeah. So a cyclist hangs a bicycle with a rear wheel in contact with the ground and the handle attached to a light string and the entire system in equilibrium, right? So I'm just gonna zoom in. All they want, same thing. Put in the forces acting and write 2 equations. That one next part. See that? Right? So do the same thing, right? Write the forces. Draw your plank, right? Draw your forces, and then get your 2 equations. Very similar to the last one. All right? Nathan will help us with this one. Right. Go up here. 1, 2, 3, 4. Dylan again, true. Dylan. Karen. Done. Kavish. Done. With TJ. Crystal. One here, the TJ. Dario. Yeah. Very book him. Yeah, it's very warm. Now we got to go. Where is called up for? But think about it, right? Huh? Yes, remember you're hanging it, right? So now we have upward force, and that is called tension. Right? That's string, the tension in the string, pulling the bike upwards. Huh? What's the diagram? And should end up with all the forces downwards. So you have reaction force. Okay, now that's our upward force. Tension always back to the equilibrium. So that tension upwards here. Right? Your reaction force, and you have your weight. Push up. Sorry. But once again, we have the right, work it out and write your three equations. Nothing to work out as yet. Although I think there's a part where they give you the mass. Now, and we'll make up a mass. So step one, join all the forces. Step two is to get your two equations. And step three, I am making up a mass, right? Let the mass of everything there be 20 kilograms. Right? Online, I would like to see some answers, right? What are the two equations? And more importantly, use the mass to find tension. Use the mass to find your tension and find your R. Go ahead. Use the mass as 10 gravity. Sorry. Use your mass as 20, gravity of 10. Do you think when you get your equations right this time? I want to give you a hard one now. I become a police. It gets smaller. Right, I only move it now. Wait, I got it. Find the mass 20, right? Take your time, do your thing. Get your two equations and then when you get your equations, see if you can find it. See if you can find the tension. Right, but it starts from a good diagram, right? Okay, Daniel. Intro. Nobody didn't put up value. Online, you can send some answers, please. Dylan. Gerard. Because you get it equations already. You have a diagram, right? Get your two equations and solve for. Right? Get your two equations and solve quickly. All right, let's see. All right, let's put it together now. Online, so let's send some answers now, please. I'll wait it all. Yeah, let's answer down here and just wait it all. Send answers. Gerard, Celine, Arissa, Jilon, Lashmi, send answers, please. Oh, wait. Right, send the answers to the host, yeah? Oh, wait, you have no answers. Come on, here, get out, please. All right, so we go in again, it's in equilibrium. So upward equal to downward, that's equation 1. Next, we using W, we taking moments. We taking moments about that point there, let's say R, and then we write in the law, watch here, we write in the law, right? Sum of the anti-clockwise is equal to sum of the clockwise. So write the law before you work it out, right? And tell them where the pivot is. So W is clockwise. So it's W by the distance from the pivot, which is 0.8. Anti-clockwise is T, right? Because anti-clockwise is T by 1.75. That's okay. Now we can easily find W. W is equal to mass by gravity. So that's 20 by 10, which is 200 newtons, sorry. Right? And then we can find for T, 1.75, carry it here. You'll get W by 0.8 all over 1.75. Right? And then you solve, we know what W is. W is 200 by 0.8 over 1.75. When you work it out, you got what? 91. I just wrong it up to the nearest whole, right? 91. All right, Narissa, nice. Nobody else send any answers. Gerard, are you there? Okay, all right, Celine. Gerard. All right, today is my last call on the parents. No, Gerard. Are you okay with that? 1 and 2? Yeah, let's go again. Right, this is a popular one that teachers like to use. Right, nice old question. This is not 2000 and something, I think. Nice old question. Again, try and turn it into a plank and put in all the forces. So diagram 2 represents a tree held horizontally by a waiter, sorry. The tray has a weight of 6 newtons and supports a drink of weight 3 newtons. The waiter provides a force at P. The tray may pivot at T. So they give you plenty of information, right? They told you where the pivot is, tell you everything that's happening. Use the diagram to find the force provided by the waiter at P and the upward force can exert at T. All right, so I'm just gonna zoom in a little bit here. Convert that into a plank, nice and neat. Some more diagram looking around tidy. I'm gonna call any names there. Right? Take your time, draw your diagram, put in your forces and put in the distances. Once you do that, 90% of your work done. And then find the force at P and the force at T. Everything else you need, you don't need anything else, right? And just zoom in there. Find the force at P and the force at T. Do not start the question until you have a proper diagram, right? Right, Miriam, you lost the last one? You saw the diagram and you saw it working on the board?
Yes, sir, I saw you working on the board, but I can't really see the last few parts on the underneath. It's kind of blurry. Looking kind of blurry. And I think I kind of lost because I come in class late and I
Yeah,
missed
I
the
missed last week.
example.
Okay, I am going to send a picture on the group, right? And see if you can go over the last one.
Okay, thank you, sir.
The dots. That's your own class, sorry. All right, so all we're trying to do here, Maria, is that we're trying to draw back a plan with all the forces and the distance from all the forces on the pivot. Right, so every force should have a distance from the pivot. Can you tell where the pivot is here, Miriam? At what point?
At P.
At
P.
P is that? No, P is where there's a force. So the pivot is at T.
Okay.
And I hear this so getting get this at C, right? So I want you to take your plank and putting all the forces the same and the distance, right? There's one small trick in the question earlier. Pay attention to the SI units. Pay attention to the SI units, right? Oh yeah, putting all the forces, putting it distance, and then the question said to find P and then find T. Take your time, let's get this one. I find T and then find T. I can't jumble up in the diagram or think too much, right? See if you can figure out, remember to put in T, right? Yeah, you're not what. All your lengths. Right, but that's T over there, that's T. Okay, but that's T. I break diagram. So your completed diagram should look like this. Right, Miriam? So I have all the forces, right? I have all the forces and then distances for the pivot. Right? So notice I didn't write 0.3. I wrote 0.25 because from here to here is 0.25. Right? This whole thing here, 3, I don't want to get mixed up because I need from here to here. That's okay? So I wrote 0.25 right now, initially. Right? Instead of writing 0.3. Fix it up. Where do you choose the pivot at, Nathan? Pivot where? Right, T. Right? So pivot at T and then apply which law you're going to use earlier. Upward equal to downward or clockwise equal to anti-clockwise. Oh gosh, I mixed up earlier. Right? Anti-clockwise moments is equal to clockwise. Go ahead. Apply the moments. Take your time, find P and then find T. You're touching on a little bit now? Yeah? And what's the most important thing, Hilario? A proper diagram, right? Well, of course, you gotta know this, right? Hurry up, can't work it out. Figure out which force is clockwise, which anti-clockwise. Again, I want to ask a question. T. What's the moment of T, Alex? If I take in the moment at T, what's the moment of T? 0. Nice. Okay. So T automatically eliminated because I choose the pivot there. Right? Like Aidan, all you have to figure out now, Aidan, is which is clockwise and which is anti-clockwise. Okay? And then use the rules. All right? All right, online, please send some answer, Jalen. Miriam, so see if we can use that diagram, Miriam, and apply the principle of moments. Come on. All right? Sure. We are bringing any coordinator. I can. Gabi, Papa. Figure it out. Still have one more. Let's have it. Still have one more, yeah? Right, so those who do the 1 year course, right? On the elements now, we have all the videos. But those are not edited, but go through them and just put them at 1.5 speed. First, when talking on a calculator, give it, get through them. When not talking for somebody. Which one is clockwise, Mega? Andy? You talk, right? Right, so the 6 and 3 are clockwise and the P is anti-clockwise. And you notice what I did. I made sure the units for distance is in meters, right? I did not put in centimeters. Two minutes again, and I'm gonna work it out. I can't do that. I just creating one more. So, all right, let's go again. Work it out. So we said that these two anti-clockwise, right? I mean, these two clockwise, right? So how far is 6 on the pivot? 6 on the pivot is 0.25. Remember, this symbol means sum. How far is 3 from the pivot? 0.4. Right? So it's this, sorry, this by this plus this by this. We force by the distance on the pivot, right? And the last one, which is anti-clockwise, is P multiplied by 0.05. Right? Add up this. How much you got? 2.7. So P is equal to 2.7 over 0.05, which is 54 newtons. Right? You got that? Gabby, since you're smiling, T is what? Well, tell me what's do now? T is equal to what? Right, so T is equal to the downward, right? So that will be P plus 6 plus 3. Right, so that's 54 plus 6 plus 3. So that's 63. Right, nervous, how are you going to 72? You'll divide it, correct? 2.7. Yeah. Anybody else get 54? Yeah. Nervous, so let's check back your working, right? Are you okay with us? Very good. Okay with us? All right, next one is yours on the board. Last one. I think I have somebody come on the board and work it down. Actually. You're okay with it now? Let's just do one more and just change in the angle of it, right? Like. What do you feel like? Right, W is the weight, Y is a vertical force, right? Oh no, this one is it. There's nothing else. Calculate the magnitude of Y. That's the best I can do there, right? Calculate the magnitude of Y. That's all they want. Just not have one out of the book. That's most funny. What is looking like, Colin? What's you pick it out fast? Like the bicycles. The one that's hanging it. Very good. Do this fast and we done. Actually, if you do it fast, we have one. Right, Miriam. So look back at the example that we just, like the one with the tricycle, and see if we can figure out this one here. It's just like the bicycle, just the numbers change. Ano yung ginamit na yun? Right? It's a different apparatus, but basically it's the same thing, same plant diagram. Like the it's not how we can think about not really big. Some machines. You have fast and work it out. Right? So whenever you're doing a question, take any habits and having this close by, right? Right? Hopefully these are the things that you should have in your head. So when you go into that question, you see, okay, I see the word equilibrium. So what does that mean? 1, 2, right? Contact force, what does that mean? Number 3 here. Right? Work it out and find y. Has been generated diagram fast then Megan. Has been generated diagram fast now. Pivot is where? Left, nice. What's the force acting here? No. What is solar force? Contact force. Then in the middle is the weight. How far is the weight from the pivot? 0.4. And then how the kilon finish already. And last force. Where's y? On the end axis. How far is y from the pivot? How much? You sure? On the pivot. 1. Right? And what the law we're gonna use now, Annalie. What the law we're gonna use now? Right, principle of movements, right? Right. Go ahead, apply it fast. And Vishish, come over again. Right, so next week we will run through next week we shall run through a few other things, the levers and efficiency and things, right? Right, so yeah, Vishish, so we're using where's the pivot? Pivot at what? Oh, sorry, there was 9. I forgot to take off this. Right, so your diagram should look just like the one with the bicycle. Pivot at. Vichy said to pivot at R. What's the rule we're using? Annalise said anti-clockwise is equal to clockwise. W, clockwise or anti-clockwise? Vichy, clockwise. So that will be W by how far? 0.4. Right? And automatically Y is what, Vichy? Anti-clockwise, right? And how far is Y from the pivot? You sure? Pivot is here. Vichy started to give you some more. And then make Y the subject, right? So Y is equal to W by 0.4 all over 1. And W is how much again? So it's 25 by 10 by 0.4. That's okay? That's all we're doing. Same thing we've been doing all the time. How much is that? Nice. Okay? So that's principle of movement. I'll give you a few more to practice. right, so yeah, one already, all right.